Hey everybody, so this is your video on the 2.1 to 2.2 review. So the first one says, for the function g of x graphed here, find the following limits or explain why they don't exist. So here we have the limit of g of x as g approaches -5. So that's repeated here, and you basically have your two choices, whether it's a number or whether it does not exist. So whenever it says x approaches -5, for example, you look here and it approaches the same thing from the left and the right. It approaches the same number from the left and the right. And so then you just choose the y number for that, and again, you know, if this is the x-axis, this would be y equals 0. And so then your answer would be 0. For the next one, it says, what is the limit for -2? So from the left side, it's -5, and from the right side, it's also -5. So you get -5. All right, so on the next one, it says, what is the limit as x approaches 0 of g of x? And so when you look at 0 from the right, which means the right, the x approaches 0 plus, the answer is 1. But from x approaches 0 minus, which means left, it would be -5. So since it's different, does not exist, or DNE. So that'd be does not exist. All right, and then the next one says the limit as x approaches -1.2. So -1.2 is part of this horizontal line between 0 and -5, and it's always the y value -5 in this graph. So this is also -5. All right, on the next one, it's a sequence of true-false statements. The thing that I'd like you to pay attention to is sometimes true is first and sometimes true is second. It kind of jumbles. You see it goes back and forth. So what I'm going to do is I'm just going to put T or F here, and then, go from there. So the limit exists from x approaches 0. That's going to be true because it approaches the same thing from the left and right. It doesn't matter that there's a hole there and that there's a dot there. It's going to be true. And then that the limit is -3. Yes, that's actually true. It's approaching -3, so that's true. Does it equal to -1? No, that's just a random dot, so that's false. Now at 2, is it equal to -2? No, only from the right, so that's false. And does it equal to 0? No, only from the left. Okay, now the next one says the limit exists at every point within the open interval from -3 to 2. So we don't care about the actual dot and the hole, but everywhere else. So in other words, does the limit exist everywhere, like even at this place? And it does. So that's going to be true. Then that the limit does not exist at 2, that's true because it's different numbers. So it's basically not the same numbers from the left and the right. Now these have to do with ordered pairs, like 0, -1. Remember, it's f of x equal y, and it's an xy ordered pair. So this is 0, -1, this is 0, -3. This is 2, 0, and this is 2, -2. Okay, so is there a point at 0, -1? Yes, there is. So that's true. And then the 0, -3 would be false. So what this is actually saying is there a point at that particular spot? And then for 2, 0, there's not a point because there's a hole. There is a point at 2, -2. So this is false and this is true. Okay, now the next one, the easiest way to work this, well, we first plug in, try to sub, so it goes 269 minus 269 over the square root of 269 plus 20 minus 17. So this would be 0 divided by, that turns into the square root of 289. The square root of 289 is 17. So we get 0 over 17 minus 17, 0 over 0. Now what that means is you need to try a different way. So there's different ways you can do it. The easiest, I think, is from a table. Try 269.0001 and 269.9999. That's a couple of ways to do it. The other way would be multiply by the conjugate. Now, when we're using the table with this, you want to change independent to ask, and then just type your numbers, because that's going to be the easiest approach. So, for example, let's go into our document, and we have parentheses x minus 269 over the square root x plus 20 and then minus 17. Notice that I don't try to type the limit part as this, I just put the function itself. So think of this as f of x, or f1 of x, if you want to. Okay, so if I go into the table, there's all my numbers. The best approach is to go to Menu, Table, Settings is number 5, and to change independent to ask. So now it's all completely blank. And again, if I type 269 in there, it'd say undefined. But if I did 269.0001, gives me 34, if I do 268.9999, it gives me 33.999, so we get 34 from the squeeze theorem. So both lead to 34. Now, the other way was to multiply by the conjugate, which is probably a good skill to have, even though you don't have to have it for this test. So we say x minus 269 over the square root x plus 20 minus 17. So for the conjugate, that means take this same thing except for make it the opposite sign. So plus 17. And I'm having to put the exact same thing on top and bottom. When you do this, on bottom, when you do FOIL, your square root cancels, so you just get x plus 20. Then your outside term with plus in front and your inside term with minus in front would cancel, and so then you just have minus 289. And then from here, when you do FOIL, first times first, this would be x square root x plus 20, then plus 17x minus 269 square root x plus 20, and then minus some really big number, 269 times 17, 4573. Okay, so I just realized even though that's correct, I probably should have kept it factored out. I was getting ahead of myself. Let me just say, should not have distributed. Should not have distributed. Sorry about that. So this should have still just been x minus 269. And this should have been the square root x plus 20 plus 17. Because down below, when you do 20 minus 289, you get x minus 269 also. And that's kind of like what the point was. So you should have just canceled this and this, and then you plug your number in right there. So you have the square root of 269 plus 20, and then add 17. So that would be like 17 plus 17, which is 34. And 34 is what we got earlier. So I should not have distributed right there, but it does work out pretty clean if you don't. Okay, so that's how you work number 3. The next one, we will do the same thing. If you put a negative 9 in here, let's see what happens. 8 minus the square root x squared minus 17. All of that divide by parentheses x plus 9. Okay, so there's your graph. And so when we go to our table, at 9 it's 0. But at negative 9 it's undefined. Okay, so since it's undefined, then try a different way. So try try negative 9.0001 and negative 8.9999, just to be sure. Okay, so let's see, control, well, we already did control. We want to go to table settings, change independent to ask, and negative 9.0001 gives me that, and negative 8.9999 gives me that. So both lead to 1.125. So remember, follow your directions. The integer means it's a plus and minus whole number, and then a fraction would be like, you know, number over another number. So not a decimal. So what we're going to do is go to the calculator and put 1.125, menu, number, approximate to fraction, we get 9/8. So 1.125, menu, number, approximate to fraction. That gives you 9/8. And so then 9/8 would be your answer. Okay, on the next one we have 2 plus 4x plus sine x, all of that over 3 cosine x. So try plugging in the 0 and see what happens. 2 plus 4 times 0 plus sine of 0 all over 3 cosine of 0. So when we're talking about 0, it's this spot, which is the ordered pair 1, 0. And remember, cosine relates to x and sine relates to y. So this would be 2 plus 0 plus sine of 0 would be the y value, which is also 0. And cosine of 0 was 1, so this is 3 times 1, so you get 2/3. So that one did work out, and you get 2/3. Now for this, we have the addition, and so basically you've got a plus sign here, and that means you could take the limit of this one plus the limit of this one. So this is basically 6 minus 7, which is -1. And on this one, we want 3 times g. So the limit of -7 is -7. So 3 times -7 is -21. This one, they want you to multiply. And so you get 6 times -7. So that's -42. And on this one, you just put the f on top, which is 6. And then it's -7. I just put the minus sign out to the side, -6/7. All right. Now on this one, the best approach for one where it's linear, since it's linear, the answer will be the slope. So think y equal mx plus b, and so the m is -9. So regardless of whatever x value this is, this would be -9 in this case. That's the quickest way to work it. There's a longer way, which would have been f of 7 plus h minus f of 7 all over h. but it's not worth going through that. And also, by the way, this comes from f of 7 plus h minus f of 7 over 7 plus h minus 7. And so that's why. So your best approach is just notice that it's a linear function, and so your answer will always be the slope. Okay, on the next one, number 8, it says 7 minus 4x squared is less than or equal to g of x is less than or equal to 7 cosine x for all x, and we want to find the limit as x approaches 0. So what this means is 7 minus 4 times 0 squared. 7 minus 0 is 7. And this is showing you basically the squeeze theorem or the sandwich theorem. So we've already done the left side. Now we need to do the right side. And this says 7 cosine x. So this would be 7 cosine 0. Now make sure if you're doing this in the calculator, you're doing 7 cosine 0 degrees. 7 cosine 0 degrees. And that gives you 7. Seven times 1, basically it's 7. And since the left side is 7 and the right side is 7, then your answer is 7. All right. Now for number 9, you want to find your average rate of change over pi halves to pi. So your function is 13 plus cosine of t. So you basically want f of pi minus f of pi halves over pi minus pi halves. So pi minus pi halves is like 2 pi halves minus pi halves, which just gives you pi halves. Now for the other part, I'm just going to put it in the calculator. 13 plus cosine pi. That gives you 12. So when I did f of pi, that'd be 13 plus cosine of pi, which is basically 13 minus 1, and so you get 12. Again, you can just use your calculator, but if you'd rather use your unit circle, over here at pi, it's -1, 0. So your cosine would be the x and the sine would be the y. So f of pi would be 12 minus, now I need f of pi halves. F of pi halves would be like this. Okay, at pi halves is 0, 1. So your cosine would be 0, your sine would be 1. So if we have 13 plus cosine pi halves, that gives us 13. So 12 minus 13. So if we did it like the long way, 13 plus cosine pi halves, that would be like 13 minus 1. I'm sorry, cosine of pi halves is 0. 13 minus 13, which would be 0. 13, right there. 13 minus 0 is 13. So over here we end up with -1 over pi halves, and then you flip it basically, and so this ends up being -2 over pi. -2 over pi. Okay, so now we need to do from 0 to 2 pi. So f of 0 would be 13 plus cosine of 0. Cosine of 0 would be cosine, sine. Cosine of 0 would be 1, so this is 13 plus 1, which is 14. And then when you do for 2 pi, f of 2 pi would be 13 plus cosine 2 pi. Since 2 pi is coterminal with 0, it's going to be the same thing. Again, if you want to check it on the calculator, you can. Going to highlight it and make it 2 pi, and then you get 14. Just like if I highlighted it and made it 0, then it'd be 14. So both of these are 14. So what that tells us is when we're doing f of 2 pi minus f of 0 over 2 pi minus 0, that we get 14 minus 14 over 2 pi, and 0 over anything except for 0 would give you 0. So 0 is your answer. Alright, now for this one, we need to plug in 4 for theta and 5 for theta. You're basically doing f of 5 minus f of 4 over 5 minus 4. And so f of 5 would be 5 cubed minus 2 times 5 squared plus 5 times 5. That gives you 100. So it's 100 minus something over 1. For f of 4, we're basically doing 4 cubed. So just change some 5s to 4s. 4 cubed minus 2 times 4 squared plus 5 times 4. So you keep that 5 there, and just, changing that, and so you get 52. So then you just do 100 minus 52, which is 48, and that's your answer. Okay, on the last two, you're using an equation and an ordered pair, and so go ahead and think of f of 3 as negative 3. You don't have to plug it in. You already know it. So what we're doing is f of 3 plus h minus f of 3 all over h. The way I like to do this is to do 3 plus h separate. F of 3 plus h would be 3 plus h squared minus 3 times 3 plus h minus 3. So you need to expand this using FOIL and doing your regular expansion. 3 squared is 9, and then you have 3h plus another 3h is 6h plus h squared. Then we need to distribute, so we get negative 9 minus 3h minus 3. So what this gives you is h squared. There's 6h, there's minus 3h, so that's plus 3h. Then you have your 9 minus 9, which cancels, and then you have your minus 3. Okay, so now that I have that part, I can say this is, I'm going to do this over here, f of 3 plus h minus f of 3 all over h really is h squared plus 3h minus 3. Now minus f of 3, like we said, was the y value, which is negative 3. So minus a negative 3 gives you a positive 3. And these cancel. Then this cancels down to be h plus 3. Now you set h equal to 0, and so your slope is 3. So then your answer here is 3. And then the last step, you either use y equal mx plus b, or you use y minus y1 equal m times x minus x1. So if you use y equal mx plus b, then you put negative 3 for y equal m, which is 3, times x, which is also 3, plus b. So this would be 9, and you subtract 9, so b is negative 12. So this would be y equal negative 3x, positive 3x minus 12. 3x minus 12. And if you prefer using the point slope form, you would get y minus, the y value is negative 3, so that's y plus 3 equal, the slope we got was positive 3, and then we go x minus 3. So this would be y plus 3 equal 3x minus 9. Then you subtract 3, and so again you get 3x minus 12. So same answer either way. Alright, for the last one, you're going to do the exact same thing, but with 2, negative 12. So f of 2 plus h minus f of 2 all over h. So when I do f of 2 plus h, with this equation, I get 2 plus h cubed minus 10 times 2 plus h. Okay, so on this one, the main thing is you got to simplify this down. I'd like to say 2 plus h squared times 2 plus h. And then I'm also going to go ahead and distribute this, and you get negative 20 minus 10h. Okay, so this raised to the second power means it would be 4 plus 4h plus h squared. Then I got to keep everything else the same. And now I want to distribute 2 times everything and then h times everything. So 2 times 4 is 8. 2 times 4h is 8h. 2 times h squared is 2h squared. And then we go to our h, which just adds an extra h to all of them. Plus 4h squared plus h cubed. And then I can't forget the minus 20 minus 10h. Alright, so what that simplifies down to is h cubed, 2h squared, and 4h squared gives you 6h squared. Then you have 4h and 8h gives you 12h. Hold on just a second. 8h plus 4h is 12h, but then you have to subtract 10h also. And then this one 8 minus 20. Okay, so what that gives you is h cubed plus 6h squared plus 2h minus 12. All right, so that's for my top part. So this would be h cubed plus 6h squared plus 2h minus 12. Now what I'm doing is I'm subtracting f of 2, so that'd be minus a negative 12, so really plus 12. And you know you did it right if your numbers cancel, which they do. And then we divide out the h to everything, so we get h squared plus 6h plus 2. So then the limit of that as as h approaches 0, this would be 0, this would be 0, this would be 2. So our limit is 2, which is what our slope is. So our slope is 2. Then we just have to get our equation. So I'm just going to do this with y equal mx plus b. Negative 12 equal 2 times 2 plus b. Negative 12 equal 4 plus b. That means it's going to be negative 16 equal b. So then we have 2x minus 16. All right, that's going to be the end of the video. Best of luck on your test.